our pre-sale support engineers. So thank you all for coming today. Just going to take you through a little bit about who we are. If you weren't on our previous webinar that we did last month, where we spoke about the whole company and everything we do, just going to take you through a little bit of what we do and who we are. We've got obviously Matt here from Solis today to talk about Solis, one of our favorite partners, and also our Installer Excellence program. And then at the end, if you do want to wait around, we do have a question and answer as well, obviously, if you do have any questions. So who are we? So Dyness was an enterprise founded in 2017. We are a battery storage manufacturer based in China. Obviously, we are now worldwide and have factories situated all over and offices all over as well. We've got over 600 employees in the team and our R&D team of 150 plus people. And these guys have a vast experience within the industry already. We own more than 100 patents and we've installed over 500,000 residential ESS units worldwide. So since the start of 2017, obviously you can see there we've got our HQ in China and 2 factories. Obviously since then we've built up markets all over the world. We've got in Sydney and Singapore, obviously the Australian market. We've got South Africa as well, Brazil, the US, and then our European headquarters is in the Netherlands. And then earlier this year in February, we opened up our UK office where myself, Alpa, the UK sales manager for the commercial side of things, and a couple of our engineers are based as well. So since 2017, we've received a few awards. So top brand PV for Brazil, South Africa, and the Czech Republic, which we're very proud of. And one of our main ones is the top battery solutions provider from China. That was in 2023. And then this year, the IF Design Award. And then just below there, you can see our certificates of conformity for each product. So we're very proud of those. So what do we do? Just a quick overview. Obviously, I will be diving deeper into the residential products, more so specific individual ones. But as you can see there on the left-hand side, top left, we've got our rack systems. That's the B4850 and the B3. The B4850 is a 2.4 kilowatt hour module. It can be installed up to 40 times in parallel. Very good, obviously, for flexible systems. Same as the B3. We have recently brought out a B4850 box, which allows you to put 2 of these in. I will be talking about that a little bit later on. We've got the DL5C there, which is a newer product released earlier this year into the UK. It's a 5.1 kilowatt hour module. Sort of a newer iteration of the BX51100, which a few of you might be familiar with. Just a little bit better performance and obviously the 1C rating. Next to the BX51100, you've got the PowerDepot H5B. So I will be running through these quite quickly, but obviously I will be diving deeper into the ones we want to focus on throughout the presentation. And so that's a 5.1 kilowatt hour module as well, the same as the DL5C, but it is IP65 rated compared to the IP54 of the DL5C. Just below that, you've got the PowerBox Pro, which is the H5B's older brother. It's a 10.2 kilowatt hour module. Both of those there, you can install up to 5 times in parallel, which then brings me on to the PowerBox G2, which is a newer product being released this year. It's the newer iteration of the PowerBox Pro. That you can install up to 12 times and better performance once again. In the bottom left there, you can see the tower systems, the Tower and the Tower Pro. There are high voltage modules for residential application. So those won't be talking about much today, but if you do want to find out more about those, we do have another webinar coming up where we will be speaking about those. But obviously you can find out all that information on our website anyway. Then just to touch on the commercial and industrial products, even though we're not going to be speaking about those, I will just run over them quickly. The LV rack and the HV rack, that's sort of your familiar system in the market, the rack systems. You then got the Power Stone, which is a 76.8 kilowatt hour system, the DH200F, which is the 215 kilowatt hour system. You've got the Stack 100 and the DH100F, both 100 kilowatt hour systems. The DH200Y and the DH300Y, which will be released, I believe, at the start of next year. Obviously, Alpa's here if we do need to ask any questions about those. But yeah, all very exciting. You know, what we like to say is we can take you all the way from 2.4 kilowatt hours all the way up to 2.5 megawatt hours right now. That is going to increase in the future, but obviously everything in between as well. So we're very flexible when it comes to solutions. So just a quick video here of the B4850 box. So that there was the B4850 box. Obviously within that, you've got 2 of our B4850 modules. Both of those are 2.4 kilowatt hours, obviously making a 4.8 kilowatt hour system. We brought this out earlier this year. A few of the UK Green Tech branches have these already, and also CCL, if you did want to pick these up. So these, basically the main idea for this was, as the market moves on and as things get more intelligent, you know, you sort of need a minimum of 5 kilowatt hours, and we noticed that. So we've brought out this box which allows you to incorporate 2 of these systems into one, effectively making a 5 kilowatt hour system. But the bonus of this also is it takes it from an IP20 rated system. So each, obviously, B4850 module is rated for IP20 to an ingress protection rating of IP54, which obviously is a massive bonus. I think the main thing with the B4850s is it allows for that flexibility. So especially in some counter projects we've seen, and solar together projects, you know, that allows you to go, I think they need a 5 kilowatt hour and then a 7.5 kilowatt hour. So we can do that with this. So it just sort of allows for that flexibility to, you know, a very minute scale. These are rated for 6,000 cycles over their warranty period, and 95% depth of discharge, which is market leading, especially for a module of this size. So it's a very, very good module. So that's how it looks there. It's a very nice looking box. It sort of takes away from the rack system look, which I quite like, and we've had a very good feedback of this so far. So I think this is a very, very good module. But obviously your lower application, smaller applications, sorry, at the domestic level. And obviously from that video, you can see there's a very simple battery installation. You just got your positive and negative cables, obviously, between the 2 batteries inside there. And then obviously, yeah, we originally released it into Ireland first, and it went extremely well. So we're now pushing this into the rest of the UK. This is a very, very good model, and I think it will take over the market within the domestic space. It's a 1C rated battery, which again is market leading. It's up there with the premium brands in terms of performance, just obviously at a competitive price. 5.12 kilowatt hour battery. This is rated for IP54, which obviously isn't the IP65 like the H5B or the PowerBox Pro or the PowerBox G2. However, IP54 can be installed outside. Just obviously we would need some form of protection. You can install up to 50 of these in parallel. So this offers that wide range and flexibility in terms of capacity, which is very, very handy for installers. You know, when they're speccing jobs, you've got that option, and a wide compatibility with inverters as well. Obviously we're joined by Solis today, but we do offer that range as well. So this is how it looks on top there. You've got your positive and negative sockets, your CAN ports, and your dip switch, and then you've got indicators there for the state of charge, alarms, and the soft wake button as well. So you can install these in a rack system. We've seen it installed majority of the time wall mounted or floor mounted, but you can install these in a rack system. And if you need a rack system for any jobs, just let us know and we can help source. We don't provide it, but we can source them for you. This is for wall mounting here. It's exactly the same as the PowerBox G2. Screws into the back, obviously screw the bracket onto the wall and then just slot that in there. And obviously if you're floor mounting it, just make sure that's fixed in place. and that's just a little guide there. Obviously positive to positive to positive, negative to negative to negative, and then feed back round to the circuit breaker and then into the inverter. Perfect. And this is just how it looks with the Solis there. So it's a very nice looking system. Obviously with the release of Solis's S6, I like to say the colorways match. So it looks like a very smart system when put together. So the PowerDepot H5B, so this is the IP65 rated system. Same for installation, just a slightly different bracket. You've got screws onto the back, which obviously slot in. And then you've got basically a ledge where you slot that into for when it's on the wall. That's IP65 5.12 as well, installed up to 5 times in parallel. This one incorporates obviously the Wi-Fi monitoring as well. So this is for our app, feeding that in. You'll see the login page there. You put in all your details. Got the organizational code there, which will be automatic, or should be. If you've got any problems with that, please give us a call. And then you just select which battery it is and connect it through the Wi-Fi module. Really, really simple. Perfect. So that was just an overview there on our products. I'm now going to hand over to Matt to talk a little bit about the Solis and what they do, what they can offer, especially in terms of service now, because they've got a lot of exciting stuff on the way and they've been doing a lot this year. So it'd be really handy for you guys to hear all about that as well. So Matt, when you're ready.
Thanks, Callum. Thanks very much. I'll share my screen if that's okay.
Absolutely.
Thank you very much. Must admit, it's actually it's pretty good to see the range that you guys have got, and I think just before I continue, we get a lot of questions, people asking regards to batteries to choose, and one of the deciding factors is actually if they have a presence or not within the UK. So I think that's maybe not something you've highlighted kind of enough, in my opinion. But obviously, I would be hammering that home if I was certainly a battery manufacturer that had a presence in the UK.
100%. I will touch on that later.
Yeah, sweet. So today we're just talking purely residential inverters. So I'm only going to show you our residential inverters. However, we do have a range of commercial inverters that are due to hit the market very soon within the next few months. So we're going to have a 12 to 20 kilowatt and a 30 to 50 kilowatt hybrid inverter, which is going to work with high voltage batteries, so it will be compatible with the likes of Dyness and some of their rack solutions that you were shown kind of briefly. We probably will do more work with Dyness in terms of maybe another joint presentation for that, probably more with Alper to show that range and show the functions and features, etc. However, today we're talking residential. So I just want to take you to the left-hand side there. We've got our sort of mainstead product, which is this S5 single-phase unit, which is available in 3 to 6 kilowatt. This is going to be the product on our market probably for another half a year, and that's due to stock levels effectively, and also there's been some changes on our Plus model, which I'll discuss shortly. We also have some new inverters that we're bringing to market. So starting off, we have an actual off-grid, a purely off-grid inverter. So that's the 4 and 5 kilowatt unit that can be paralleled up to 6 units. So you can create up to sort of 30 kilowatt system. That's not going to be certified for any grid, so it's a purely off-grid application that has a generator port to charge the battery based on SOC, for example. If you are familiar with the Solis range, you're probably wondering where our current REI, or as it's now called, the S5EA 3 kilowatt unit is. We're actually going to be replacing that model with the S6 imminently, so this model's pretty much available now. Distribution will be placing orders, and it should probably see in the market with shipping times from factory. So what's changed about that is instead of it being a 3 kilowatt, we've got a 3.6 all the way up to a 6 kilowatt AC coupled inverter, which can do 125 amp charge and discharge. So We had a lot of requests for that, so happy to bring this to the market. You can also see it doesn't have a screen, so on that model in the middle of on the right hand side there, we actually use Bluetooth, so all of our new inverters are going to be able to, even if it has a screen, it's going to have the capability of doing it through Bluetooth. So the current S5 range doesn't have that function. The newer inverters will. And then if you look at our last inverter there, this is the Plus model. So this is the model that you'll see hitting the market next year. If to cover probably 90% of installations, the S5 is completely perfect, great unit, solid, and we've supplied thousands into the market. But the features, some of the features we can talk about in the S6 just now briefly, would be we have an additional AC port, which can be used for extended backup through using a generator, or you can use it as load control. So we have different features that we can have on that, but we do have more specific webinars to the S6 range that we can maybe share with you if you want to get in touch. But that won't hit the market until probably March next year. One of the other features as well is we'll be able to parallel these units. So the S6 Plus, you'll be able to parallel multiple units. And we obviously have an 8K, which is higher than we've ever been able to supply. So we'll really look forward to that range when it hits the market. So keep your eyes peeled when you see it. But today I purely want to focus on our hybrid inverter. So we're just going to talk about the logic of the hybrid inverter, some of the considerations when you're installing. We'll look at some of the stuff you can do remotely through Solis Cloud, and we'll talk about maybe some tips and tricks that you've maybe not considered before. So feel free at any time if you want to post questions, because we can revisit them at the end. If as you see it, we can answer them. So where I want to start off with is the actual unit itself. And what you get in the box effectively. So at Solis, we've tried to make it as plug and play as possible. So if you look at the bottom of our inverter, it is literally just plugging ports in. What we have is we've got our PV input, of course, our MPPTs, which we have the DC isolator on the unit. So you have an integrated DC isolator. We've got our battery connections, which obviously was where you would connect your Dyness battery in, as shown. We have our AC ports, so we have 2 AC ports on this model, whereas the S6 is going to have 3. So this model just now has 2 AC ports. One is the grid backup port, and one is just the normal grid. So we use our backup port for extended for times when we have power cuts, but we'll discuss some of that logic in a few slides' time. We have a COM port. So as it stands, our units do not come with any form of monitoring. You have to purchase that separately, and I'll show you the different models that are available to us when we talk about that, the data logger range. We then have the meter. So in the box that comes with the S5, we actually supply you with an Eastron meter, so an Eastron single phase meter, which you can RS485 back to our inverter, which is where we get the communication and how we monitor what's happening at the grid. We also have the CAN port, which is massively important, especially in collaborations with the likes of Dyness, because ultimately our inverter has to work with the battery. And when I say work with the battery, we are effectively a slave to the battery. The BMS does most of the calculations from what actually is required, how much power we can take, how much power we can put in. It'll all be driven from the BMS sending a signal to our inverter to how much current we can put back into the battery. And then we also have another thing called the DRM port, which is not hugely popular, but all of our inverters do have that, and it's ultimately just a 2-wire start. That if you enable that function, you can turn off the AC or open the AC relays to stop production. Normally, that's if you are using a backup generator on site and you didn't want to be generating any power at the same time as running a generator in case you come into issues with backfeeding. But in the box, what you get is your inverter, the backplate, some screws, the plugs for the AC terminals. We supply you DC connectors, hugely important, guys. We use Stobly MC4s, and what we've seen in the past, maybe more on a commercial scale, is that customers are using cheaper alternative MC4s and connecting it and mating it to our inverters, and then having DC arcing, which can cause melts and due to bad contacting and arcing. So we do supply you the equivalent compatible MC4s to connect to our inverters. So please use what's supplied in the box and maybe not something you've sourced elsewhere, just in case they're not Stobly, for example. We supply you some battery cables. So on the battery cables, we have one side Amphenol, and then the other side is ring terminal. So Amphenol is just the sort of push connector, which is at the bottom of our inverter, but the other side is a ring terminal, which you can use to connect to, for example, a battery breaker. And then you can use the Dyness cable from the other side, from the battery breaker down to the battery. I'm sure Cam showed a slide earlier on that kind of demonstrated that. We then have the meter plus the CT. So there's some important facts that we'll talk about the meter in a short while in terms of positioning and to do with the CT cable. And then we also have the manual, of course. That's ultimately what you get in the box. So everything is as plug and play as it can possibly be from a Solis perspective. So you should be able to do the install based on what you have. We do also have in our manuals with the suggested tools that you have. So you can also consult the manuals through our website before you even approach site, so you're fully equipped with all the information you require. In terms of installation and selection of where you place the inverter, something that's probably overlooked more than it should be from an installer side, and what I see a lot on social media and a lot of pictures that are sent to me, is customers not taking into consideration the airflow around their inverter. So inverters work by derating based on temperature. So if the temperature is higher, then the output's lower. We also have a caveat in our warranty that if you don't follow our instructions, then it can lead to not being under warranty. So again, please consult the manual, understand what the limitations are, and then follow. So basically, ultimately, the distances are between another inverter or a solid wall, for example. If it's like trunking, then it's not an issue, but it's something that can basically bounce the heat back or have a negative impact in how much heat or how much air gets around the inverter. So we're talking mainly about other inverters and walls. So this is what these limitations are. On the right-hand side, you can also see it's the derating curve based on what the temperature is. So you can see as it gets closer to 60 degrees, you can actually lose almost 50% of your rated output. So that's massive for your customer. So please consider that as you're doing it. Just a quick example of what we see in the manual for our wiring side. Ultimately, we have an RS45 connection between the inverter and the meter, and the meter can be installed at the grid point. When we talked about the meter selection, the meter position, should I say, we always want that as close to the grid point as possible, and then not touch the CT in terms of extending or cutting the CT to the meter. If you do that, then you can have inaccuracies on the meter. So it's always important to make sure that you have the CT cable not touched, and then extend the RS45 side. So we'll show you the pins that you use in the inverter and how you get power to the inverter, plus where you plug in your CT. What's also hugely important is to do with the direction of the CT. So if you don't have the CT in the right, obviously, direction, then your inverter logic will not work properly because it will be reading the wrong values. For example, instead of seeing export through the day, then it would read export at night when you're actually importing energy because the CT is round the wrong way. So it's hugely important, and if that CT is round the wrong way, then it's not going to operate properly. We have the backup port here, which, again, as I said, is used for critical loads, it's saying here, but ultimately customers could use it. We see applications where customers just want a few sockets so that if they did have a power cut, they could turn a light on. What we would always kind of advise is that if they were putting critical loads on it, then they would maybe suggest putting a transfer switch between the grid and the loads, so that only in the event that the inverter fails and the grid fails, that you don't have the critical load. Because ultimately what you wouldn't want to happen is in the event of a power cut, in the event of the inverter failing, you have the AC grid, or maintenance needs done on the inverter, for example. You have the AC grid there, but you can't supply your loads because it's connected to the output of the inverter. So always consider that when you're doing that. And then we have our DC inputs. So our DC inputs are battery and PV. We'll talk. I've got a better slide that shows you kind of more of the DC side of how that works and explains some of the things that maybe you've seen and you don't understand. The other point to note about CTs is that if you have it connected on the wire but don't have it clicked properly, so if you look at the bottom right hand of that slide, if you don't have it completely closed properly, then you'll not get accurate information to the meter. And then if you don't get information to the meter, then the inverter doesn't understand what's going on. So that's the sort of general installation for it. And then when you have the inverter, actually, when you're about to commission it, our inverters can work in a few different modes. So there's sort of three main modes that we have. So the first one that you probably see 99 times out of 100 in the UK, and that's the self-use mode. So basically that's job is to use the meter information and then use as much PV as it can in order to save on your energy costs. So the PV supplying priority is that the PV will supply the load first, any excess goes to the battery, and if your battery is full, then it goes to the grid. For in terms of when there's load support priority, then it's PV first, then battery, then grid. So if your load requires energy, it looks for the PV first, then the battery, then the grid. Feed-in priority is the other mode, but that's only really used in countries where the cost of energy export is higher than what it is to store it. So it means that basically your inverter just works like a normal grid-tied inverter, where it never ever stores it in the battery. It will always supply the load, then export all available energy to the grid. That means that when you're looking to use a battery system in that point, it has to have like a time of use. So the country might have like an economy 7 tariff, but they still want to export through the day. Then they can do this, and then ultimately your battery only works by time of use charging. So it will only charge based on you selecting a window for it to charge. And we'll talk maybe about the time of use because it's quite important. So that feature is available on both working modes, and it's where you can set up a time window to say if you had like an EV charger, for example, and you have a specific tariff or like an Octopus energy tariff, you want to charge your battery up based on cheaper energy, you can set that up via the app, via the browser, or actually on the inverter itself. So you can set these time windows up so that you can save your energy. The last mode we have is off-grid mode. What's hugely important to discuss on that is that basically you're putting the inverter on all the loads on the backup port. So you need to consider the size of the nameplate of the inverter. Is it going to cover your loads? And then also it takes away the message for an alarm, so that if you had like the grid failed in normal self-use, for example, if you had the grid fail, your inverter would come up saying no AC grid. What the off-grid mode does is it basically tells the inverter to ignore that. So that's the main difference. It's just to ignore the fact that it has the no AC grid alarm. We do have changes, obviously, when it comes to the S6, because on the S5, you currently cannot connect a generator to charge the battery in an off-grid mode, whereas in the S6, because it has a generator port, we will be able to do that. Again, we can do further trainings on the S6 as it gets closer to its release date. But for time being, we're talking about S5. Hybrid logic. So we've now put the inverter into self-use. So the inverter's job now is to reduce your energy costs. So basically that's determined by the Solis meter. So the Solis meter reads the CT and decides is the energy importing or exporting. So if we're exporting energy, then the hybrid inverter knows to put that much energy into the battery on the DC side. If the CT is reading import energy, so for example, at nighttime, then it will read a value that the grid, we're pulling energy from the grid, then the hybrid inverter will know in order to discharge that energy back onto the grid port. because its job is to keep that CT reading 0 as much as possible. What does happen is, because it's dynamic and there's signals getting sent between the CT to the inverter, it's calculating that, and then the load is also fluctuating. You can see sort of overspill. So what you might see is that you might be pulling 40 watts for the grid for a short period of time, or you might be exporting 40 watts for a grid, but it's basically just a balancing act. So it's dynamically figuring out what the load is doing, what the grid is doing, and what the hybrid inverter is doing, and then sending signals to the inverter in order to react to that. So one thing we do see, and we will talk about it in Solis Cloud later on, is our information sent to Solis Cloud, and it has like a snapshot window, and that explains when a customer says, why am I buying energy from the grid for 40 watts when I have battery power? Ultimately, it's just doing it for a split second, and then when it's taking that screenshot for Solis Cloud, it's just a snapshot window. Hopefully that kind of clears up some of the questions that you might be getting from your customers, because we do get asked that from end users, but ultimately that's what's happening. Another hugely important thing to talk about is the PV and battery. So on the DC side, so you can see in the middle of that diagram there, we have the inverter right in the middle, the DC side into the AC, but the DC side has a charging circuit. So what that does mean is, for hypothetically, we have a 5 kilowatt PV array, and maybe, for example, a 3.6 kilowatt inverter. What is possible is that the PV can be pushing 3.68 kilowatts out of the inverter, and then also using the additional PV energy to charge the battery. So that only is possible if the capacity of the battery is low enough for you to be able to put that energy in. But for example, if it was 100%, then the inverter would clip the PV energy. So we do have customers ask sometimes when they look on Solis Cloud why their generation curve is much higher than what the rated nameplate of the inverter is, and that's the reason. It's because you can actually charge on the DC side straight to the battery. So it's a DC charging circuit, so you can see it as a diagram explains there. Hopefully that kind of clears up maybe some of the questions that end users might ask you in terms of the monitoring, because I know that that's sometimes a big thing. Actually, in terms of the commissioning side of it, as we said, it's kind of as plug and play as possibly can be. So once you have the inverter set up and you have the battery selected properly, then you shouldn't necessarily have to change too much afterwards. There might be a few additional things that I'll talk to you in a minute about, but ultimately you have to set the time and the address, set the time in terms of the date and the time, and that's hugely important. Ultimately, if we are doing fault finding, we need to understand when exactly it happened so that we can look at it. It will also affect on Solis Cloud. If you have the timing set wrong, then the hour windows on Solis Cloud is wrong. So everything's moved along based on what your time set is. So hugely important to make sure that you set the correct information on the inverter, because that's the information that will send to Solis Cloud. Setting the communication address. This is always set at 01 by default. We have had customers accidentally change it. If you do have an issue and you set the slave address to 02, for example, you can go in and change it at a later date. However, what you would see is you would see an issue with your data logger, because your data logger is always looking to try and connect to the 01 inverter. So if you're having issues with your data logger, then the first thing we would probably check is the address on the inverter. Grid code, another massively important setting. If you don't have the correct grid code setting, then you could have over voltage alarms or alarms based on frequency, etc. So if we tend to see any issues with the grid in terms of alarms, then the first thing we do is make sure that you set the correct grid code. You'd be surprised at the amount of times that actually is the issue, but ultimately that's what we do. Set the export if you need it. So if you want to change the backflow power, so for example, you had a 5 kilowatt inverter, but the DNO have come back and said you're only allowed to export 4 kilowatts, then you can actually set the backflow power. Because we already have the meter in place, that's where that information came from, and then we can do it directly off that and then set it up. Our inverters are G100, so you should be no issues in terms of applying to the grid for that. You then go into battery select. So in this case, you're going to select Dyness, which is basically the CAN protocol between the inverter and the BMS. And then you should then have communication. You should then see it on the main screen, the battery and its SOC. We'll talk maybe in the next slide about some of the maybe issues you might have in terms of the CAN communication. You then have meter select. So we have a few different ways. Sometimes our inverters, that if they've been made for markets like Germany or Austria, or they somehow managed to make it into the UK market, they might have three-phase meters. We did historically have three-phase meters also. They are bigger in size, so sometimes they can be an issue for boards, etc. But you might find that the inverter comes with a three-phase inverter. It is possible to use a three-phase inverter using just a single phase or the L1 of that meter. But again, you can contact our service department and we can talk you through that. Or we can look at getting you a replacement meter if it's really required, but it does work as normal. You then look at the storage mode select, so that's when we talked about the different storage modes. So we have self-use or feed-in priority. So as I said, 99 times out of 100, or probably 100 out of 100 in the UK, you're going to set it to self-use mode. Once you're in self-use mode, it will then prompt you to set charge times or the time of use. And that's where you can set up 3 charge windows. So the charge windows are based on current, so you always set the charge current and then the time window. I didn't really discuss the discharge window. What I will say about that is that it's not common in the UK to use a discharge window, so you would kind of ignore that. Ultimately, if you set a discharge window, if you said between the hours of 12 and 2, I wanted to discharge 50 amps, then it would just take the energy from your battery, ignore what's happening in the meter, and then discharge 50 amps. So what you would see is you would see the load get covered, then the rest would just be exported to the grid. So that's not really what you want unless you have a high export tariff, for example, which we have seen with some Octopus saving sessions, for example. Customers have done that. So in general terms, you wouldn't really need to use the discharge window at all, but it's there as a function if customers did want to do it. The main windows is charge, and you have 3. Also, one thing to note is with the new S6 range, we'll have 6 windows, so we'll have more windows and slightly more options in terms of how we select the windows, etc. But we can talk about that probably in the next training session closer to the time. Once you've then set up the inverter, we would always suggest that you have a data logger installed, which means that it goes to Solis Cloud, which in turn means that if you have any issues, that you can contact our service department, give them the plant ID, or give them the data logger serial number, or even the inverter serial number. We can search that through Solis Cloud, and then we can also do some remote fault finding, etc. So I'd always suggest having monitoring on these systems just for that fact. So that's you now set up the inverter. So when you go back to the main screen of the inverter, you have a few sort of small indicators to understand that the system is working properly. First one on the left-hand side is it CAN OK. So sometimes you might see CAN null, which means that the cable's not being plugged in properly, which means it's just that CAN port is not connected to the BMS. Certain batteries have different CAN cables, so the pins are swapped at one side from the other. So on the cable, you might see it says battery side, and then on the other side, it'll say inverter side. That's hugely important. So make sure you've A, got the right cable for Dyness, and then B, have you plugged it in the right way around. And that's what you'd see if you had CAN issues. You would then see the SOC of the battery, so that's another indicator to make sure that you're actually getting the correct information from the battery. You would then see how much power is going into it or out of it based on what at that present time the flow of the system is. That's also real-time information, so it's not like the 5-minute delay I discussed with Solis Cloud. That's actually on the screen, so you'll be able to read what's happening. The bottom right-hand side, you see the backup port, so that's where the light bulb is. So if the customer has loads connected to the backup port, you would see what's actually running through the inverter to the backup port, and if they don't have it, then it'll just have 0, of course. You also have the PV side in the top left, which will show you how much PV you're getting into the inverter. And then on the top right, there's a few things we need to look at there. So first is the load. Is that value look accurate? For example, if you turn on the kettle and it went up to 2-3 kilowatts, then I would suspect yes. If you switched it on and it went up to 10 kilowatts, then I would suggest that maybe the readings are wrong. If, for example, you see zero load there and the export is high, then that may be an indicator that the CTs are around the wrong way. So, for example, there's no PV production, there's no power coming out of the inverter, but the CT is reading export, then that would be an indicator, for example, that the CT is around the wrong way. You can also see on this where it says 0.02 kilowatts, if you were looking at the customer smart meter and it was showing you a value of maybe 1 kilowatts, 2 kilowatts, for example, but you were saying zero there, but it said RS45 OK, then we would always indicate that that's an issue with the CT. So on the meter itself, you can actually scroll through. So on the Eastern meter, you can scroll through the menus, and you can see what the live current is, what the live voltage is, and it'll read that information. So, for example, it will show you voltage because you've got it powered, because that's where the voltage reference is, but the CT is reading the current of the cable. If that's at zero, then you would check the CT to make sure, as I said earlier on, that it's clipped round properly, or if it's not damaged. We have seen issues with the cables maybe not being tightened fully into the meter, and for whatever reason the cables have fell out, and we spend a day diagnosing remotely, but ultimately it's a problem on site. So this is stuff that you need to check. RS485 OK. If that's came up saying RS485 fail, then you're aware that there's an issue between the meter and the inverter. So you check the meter first of all, just to make sure that that's doing the readings. So scroll through, and then from that point you can then take your DC multimeter to make sure you're reading voltage on the RS485 A and B, and then you can also plug it in at the other side just to make sure that you've got RS485 at the other side. So these are kind of fault finding stuff that we normally check based on just looking at that screen. So before you leave site and you've installed an inverter, make sure that screen is pretty accurate in terms of what you would expect it to see. If not, you can call our service line. We can go through that, but we'll discuss how you do that process later on. I did discuss that once you've set up the inverters, we probably don't want to actually touch the system. But there is some examples that you might want to. For example, you might have had a brand installed and you wanted to move it to a Dyness. So you look at this new battery that Callum was discussing that has the heater, for example, and you wanted to install it outside. So you think that's for me. You want to change the battery you have. So what you need to do is go into advanced settings. When you go to advanced settings, it'll ask you to enter a password. So our passwords to get into the advanced settings is always 0010, or on the screen it'll be down, down, up, enter. And then you can go through our energy store set menu, then battery select. Once you then select the battery, it'll prompt you to set two values. So there's actually technically three values that you can in your head think about with your battery, but for setting up purely the battery, we need to figure out how much of the battery do we want to be able to use. So if we look at the data sheet for Dyness, for example, and they said we want you to work within 100% and 10%, then you can set it to 100 and then overcharge SOC at 20% or 10%. By default, it's always set at 20%. So that means that in normal operation between 100% and 20%, it will just oscillate. So it will charge the battery full to 100%, then discharge to 20%. We also have a forced charge SOC, which basically means that, for example, the customer goes on holiday, isolates the PV or the DC strings, but the battery is still keeping the inverter alive. So it has its own natural impedance plus also the load from the inverter to keep it alive. It will discharge further than 20% because it's not something that it can control. And then once it hits 10%, the inverter will then turn on the AC side to charge the battery back up. So you can set those values of how much power you pull back up until what percent. So ultimately, it's just like a safety net for your battery system to allow you to protect the investment, ultimately. The other value that we didn't discuss there is in another setting, and it's called battery reserve, and that's if you have the backup switch. So when we talked about having a critical load, the worst case scenario for you is to have the grid fail at 7 in the morning when there's no PV and you've discharged the battery through all the night, and you don't have available power for you to supply your critical load. We do have another setting which is called battery reserve switch. Battery reserve, And that means that you could set, for example, that to 50%, which means that the battery would then oscillate between 100% and 50% all the time, and then it would leave that between 50 and 20% available for you to discharge when the grid's not available. So typically customers will increase the battery capacity of their battery bank, but then use less of it in normal operation, but leave some in reserve, so that if there ever was a failure of the grid, then they would have power available. Hopefully I've explained that properly. I feel like I kind of waffled a bit, but hopefully that was okay. If you wanted to change this time of use on the inverter itself, you can do it by going through the menu structure. So going into the work mode, time of use, selecting storage mode, select on, and then it will take you to the time of use windows for you to set up. Most of the time people do it through Solis Cloud or through the app, so they don't actually need to actually have to access the inverter at all. But if you customer for whatever reason wanted to do that, they can also do it on the actual unit. That's your inverter setup, basically, and it's ultimately down to the communication side. So when we talk about the data loggers, we have a few different data logger options that the customers can select. On the left-hand side, you'll see our S3 Wi-Fi ST, which is kind of the main unit you'll see in most of our distribution channels just now. That's our sort of bread and butter, cheapest one we supply, and it only supplies Wi-Fi. They have the same casing for a GPRS version, but what I would say about GPRS is that customers get caught out by using the wrong SIM cards. They try to use like 4G SIM cards, for example, on a GPRS, whereas you can only use 2G or 3G or machine-to-machine type SIM cards for that unit. We're then bringing out a newer model, which is going to be available in the next couple of months, I'd imagine, and it's the S5 Wi-Fi. So it's this kind of newer look style that we have. So it's the black casing. It does have Bluetooth in it. So what we're hoping from this side is it will allow customers to easily change the Wi-Fi provider. So we do get a lot of calls from end customers where they've maybe changed from one provider to another, and they're trying to change the Wi-Fi. So what the customer can actually do via their app is connect via Bluetooth and then change the Wi-Fi settings on that. So it's a very simple and easy process. And also one of the update features of this is it will connect to 5 gigahertz on the routers, whereas the S3 is currently on 2.4. So we've updated that. The next version we have is the S2 WLAN stick. So it's Wi-Fi and LAN. So at the bottom of the unit, it actually has a screw which you can take off, and then at the bottom it has an Ethernet port which you can connect directly to the router, or you can use it purely as a Wi-Fi. I do have a USB version there, but I would ignore that just now. That's going to be more on the S6 range. So all our current range just now is 4-pin connectors, which is basically what you see on the left-hand side of them. The other variant we have is the W4G. So if the customer didn't have any connection to the internet, you can use the 4G version. So this is just like the GPRS, but instead it's the Wi-Fi and 4G. They can also use it in such a way that it has Wi-Fi, but if the Wi-Fi cuts out, then it'll fall back onto the 4G SIM for backup. Or you can just use it purely as a Wi-Fi or 4G. Connecting, once you've connected your data logger, we have some form of troubleshooting you can probably do yourself on site. So we have 3 lights on all our data loggers, whether or not it's horizontal or vertical. They all indicate the same stuff. So one is green. Green means that it's connection to the internet. So for example, if you had the amber light and the power light on, but no green light, then you would find that the issue is that you can't connect to an internet source. If you see that flash blinking really fast, it's trying to connect to an internet, but it's not able to do it. So it's probably an issue on your end. If the green light's on and the red light's on, but you don't have the amber light, then that basically means that the data logger stick is not capable of communicating to the inverter. So when we discussed earlier on about the address of the inverter, so one of the things you would see is that you would have no light there if the address was set to 02, because it's trying to search for 01. So the first inverter, the master. You then have another couple of things which I'll show you in the next slide on how you can diagnose if set to the right address, but you still don't have that light. And then the last one, if there's no red light, then no light will be on. So that means that there's no power getting to the actual data logger. So the power comes from the inverter, and the RS-45 communication comes from the inverter. So what we can do at the bottom of our inverter is check if you're actually getting these values coming out of the inverter. So, for example, if no lights were coming on in the data logger, and we checked the pins here, and there was no voltage between pins 1 and 2, then we know that there's a problem with that port. Then you would call our service line, explain to them what we've done, and then we would take action from that point. They might ask you, for example, sometimes the cable and internal can disconnect from the board, and it's just a small sort of bus connector. They might ask you to put that back in, but that's something that service would always ask you. It would not be something that we would ever expect you to do on your own back. So you would contact our service department. They can talk you through that. If, for example, you did read voltage there, then that would indicate that there's a fault with the data logger. Then we would just RMA and send you a new data logger. If you are seeing no amber light, then it's the same situation. So we would check that your inverter is definitely producing the RS-45. So we measure the pins 3 and 4, which would read the values of 1.7 volts roughly. If we read that, then we're happy that the inverter's actually producing that and sending it out to from the inverter. If not, we would contact our service department, explain what you've done and how it's been checked. That's just some fault finding on the data loggers. Solis Cloud, I just want to quickly run through some of the Solis Cloud, what you can see and what you can maybe do and change. So once the customer has the hybrid inverter installed, they have the data logger in play, they've set up the plant, so the installer set up this. If you're not familiar with that process, we do have YouTube videos on how to set up yourself as an installer and do this on behalf of your customer. So we do have a lot of information available to you if it's the first time you've ever used Solis. But what you would do is you would set up a plant for the customer, so the customer becomes the owner, so they're the owner of this plant, and you become the organization that's made it or installed it. So you can still have access to their system, but ultimately they're in charge. So for example, if they fell out with the installer, then they can remove the organization from their account, but ultimately they're the one that bought the system, so they're the owner. What they do is they then have access to their plant. When you look at the overview screen, which is more designed towards your end users, it's basically going to show you a sort of real-time snapshot of what's going on at the top, so you can see the sort of energy flow in terms of what you're seeing there. And that's just what we discussed earlier on, that every 5 minutes Solis Cloud sends information to from the data logger to Solis Cloud and displays it here. So there might be times where you see periods of like 40 watts either exporting or importing, and it sits there for 5 minutes, and then the customer gets a bit worked up in terms of why is it not working properly? Again, it's just reiterating that it's just a snapshot, so it's every 5 minutes it will send an update. Best things to maybe want to look at is, for example, the energy imported and exported values. If they were worried about how the system's performing, they can actually see that through the day. But for sort of general snapshot looking at it, it's not worth worrying about, in my opinion. At the bottom of this screen, it shows you the load profile. Because we can monitor what the grid point's doing because of the meter, we can do calculations to say what the load is. So if we know that you're exporting 1 kilowatt, but you're producing 3 kilowatts, then the load must equal 2 kilowatts, for example. So that's how that calculation is done. It's by knowing what the PV is generating and what the grid's doing by importing or exporting. You can then calculate what the load is. It then plots a load profile throughout the day, and then you can see the SOC climbing. So on this, for example, you can see there's a time of use window because it's completely ignoring what the load's doing. It's just charging the battery between the hours of 12 and 5 there, by the looks of it, up to 100%, and then slowly discharges through the day to offset your energy costs. So you can see all this information. You can also flick back per day on that. So you can see per day, you can see per month and per year, and then you can also select total. So there's a few things that the customer can do just basically as an overview. And that should be good enough for your end user. When we talk about installers, we wouldn't expect you to use this screen. We would expect you to use the device tab, which we'll talk about shortly. This is just the same window, except on the top right-hand corner, you can see that we've changed it from a diagram to actual values so the customer can quickly read them. So if they weren't happy with the way the diagram looks, they can actually just pull this information off and see exactly what it is. We then have the device tab. So this is where the installer should live. And we have sort of a few tabs at the top. The one to ignore is meter. The meter information comes through the inverter because it's RS45. So that's always going to be on the inverter. So in terms of the tabs at the top, just ignore the meter side of it for the time being. The main things that you're going to be looking at on the residential side is the data logger and the inverter. When you go into the data logger tab, you can see information like Wi-Fi signal, for example, if you have the Wi-Fi data logger. And if you see that was a low signal, then you can maybe understand why some of the information's not pulling through. And then from the inverter tab, we can see some real information. So when we pull information from the inverter, we can actually plot it on a graph. So this is very useful when it comes to fault finding, especially with hybrid systems. So we have a number of different things that we can actually look at and compare. So you can see that you can select multiple variables on the left-hand side, and then you can select which day it is. If you select month and year, then it will dramatically reduce what you can actually see. It will be sort of more general information. But if you're looking for specific information on the inverter, you have to go per day. So per day, and then change the variables on the the left-hand side. Where this does come in use is, so if we look at some of the values you can actually look at, is to do with inverter, grid, and battery. So inverter means that's information directly given from the inverter to Solis Cloud. The grid is the meter information. So if you had, for example, you could check the AC voltage of the inverter versus the AC voltage measured at the grid. There's stuff like that you can check. And then you have the battery, and this is from the BMS. So the BMS is actually sending this information to our inverter, so we can actually read values. And this is hugely important, especially coming into winter months. This is where we see a spike in service calls regarding battery education. And that's to do with operating temperatures. So Callum mentioned earlier on about operating temperatures between sort of 0 and 40 degrees. I'm not quite sure the exact value, but ultimately, closer a lithium battery gets to 0, it will reduce the amount of charge current it wants to take from the inverter. So it will send a constant update to our inverter through the CAN communication to say, we don't want as much power. So this is hugely important when it comes to winter, because what can happen in the scenario is that your battery's never fully charged properly, which means that the cell balancing never ever properly gets recalculated. And what we see sometimes, and not specifically with Dyness, but across all batteries, is that we see jumps in SOC values based on recalculations of BMS. And that could be that the customer hasn't had enough PV to charge their battery for 2 months, for example. So it's sat at between 20% and 40% over winter and never had a chance to go above. So what we would typically do there is we would select on the right-hand side, you can see in the last column there, the battery charging current limit, which is a key indicator that it's a temperature-related issue. So if the BMS is telling us it's sitting at 20% and it's saying zero current charge limit, then we know, for example, that the battery is too cold for it to accept power, and there's nothing the inverter can do at that point. One of the things we do see is customers putting on time of use, so charging the battery through the night from the grid, even if they don't have a smart tariff, because what you do is you ultimately use that energy back. You do have conversion losses, of course, I understand that, but what you do have is that the natural chemical process of charging and discharging has its own internal heat, and it tends to have less issues. So what I'm concerned about is the recommendations for not putting batteries in lofts or attic spaces will lead to more people putting batteries outside, which is where it becomes hugely important when we discuss this new battery range that Dyness are maybe coming out with the heaters involved. So because it has an internal heater, it will obviously use more energy and probably less efficient in terms of the overall ecosystem. It will save the investment for the customer, especially in the locations that you're putting it. Again, if you're in a cold environment and you don't have the grid, for example, you do have discharge current limits based on temperature also. So that can lead to trying to pull more battery power from it than it's possible to pull from at that specific time. So, for example, you could have a 5 kilowatt inverter. You're trying to pull 5 kilowatts from the battery, but it's only allowing you to pull half of it, for example, so 0.5 C. So it's only allowing you to take 2.5 kilowatts. Then you would overload the system, and then it would shut down. So these are things that need to be considered in terms of education. So where you locate your batteries, where you locate your inverters, and how your customer expects your system to run. So if you can get customers signed up to smart tariffs, I do believe that that's one of the main sort of things we see that kind of resolves majority of issues. But hopefully with the newer range of batteries that Cam discussed, that you should be able to look at that as an option. So that's most of the stuff we do from our side. So we take all this information, and depending on what the alarm is, we look at the timestamp, which again is hugely important when you set up the inverter. You have that set correctly so that we can understand exactly what's happened, when it's happened. So this is the alarm message that the customer will see. So if they had, for example, grid interference, it'll tell you how long it was happened for, when it happened, and then it'll give you some key indicators to understand what you should maybe do. From our side, we then go into the alarm, check the grid, check the values at that point to see if there's anything untoward that we can see. And that's how our process works for fault finding. So that's on the alarm page. In terms of the actual inverter, we have some stuff we can do remotely. So when you sign into the inverter, you go to the device tab, you go to select the inverter you want to control. Once you've selected the inverter you want, you can then select inverter control in the top right-hand corner. It will prompt you to put your password in again, and then just accept terms and conditions, because ultimately you're changing settings in the inverter, so we need to make the customer aware that if they change settings, then it's their liability to know what they're doing with it effectively. So in 9 times out of 10, the only thing they'll ever want to change is the time of use windows, so setting that up. So once you've got into this setting, you can then click batch read. It'll then populate what the current values are, and then also you can change whatever you want, so you can click save. So once you've selected from the drop-down menu, you click save. If you look at, for example, the charge and discharge window, you can click view, so you can just see exactly what's set up, what time windows have been set up, what current's been set up. And if you wanted to change that, you just click on settings, and then once you do it settings, you click save, and then it'll send the command to the inverter. So it means that you can change the time of use remotely. So that's, again, you can do that through the web browser, which is what's shown here, or you can do it through our app. So our app can do that for you. Just moving slightly on to our service side. So Callum did kind of touch on it briefly from Solis side. We go back maybe 2 years ago, we had an issue in terms of the influx of customers installing Solis inverters versus number of service staff, which led to a disappointing time in Solis's era. However, I'm glad to say we've rectified it. I don't think any service department will ever be 100%, and I don't think we'll ever settle, and don't think we're ever good enough until such times as we're no longer in business, I'd imagine. I don't think anyone should settle on service. But from our side, what we've done, we have a few things in place. So ultimately, we have a service line, which we divvy up now. So from when you call in, we have installer on-site option. So once you select the installer on-site option, it puts you as a priority. So you're a priority in the queue, and you are basically shown to our staff that you are waiting on site in front of an inverter. If you're not on site, so it's not like a critical call, effectively, you can basically call a reception. So a reception takes your name, number. If somebody's available, they'll speak to you. And if not, they'll create a ticket. And then one of our guys, that when they're not dealing with installing on site, they'll get back to you. We can also create a ticket. So once you create a ticket, we have our India team, which can answer you within a day. And then we also have the product solution side. So this is where I come in. So my job is to make sure that any questions in terms of design or product knowledge is answered out with the service, so that we don't have a situation, or we're trying to avoid the situation of you having to call our service line to ask an educational question, for example. So you can contact me directly, or you can create a ticket, and it'll get passed through to myself to speak to you. But yes, so we've done a lot. We've hired more staff. So I think we're now in the region of over 100 staff across Europe, which I think in the region of about 15 is specifically for the UK. So the UK is the biggest market in Europe. So they deal with all our calls and tickets. If we are short of numbers, we have the situation where we can pull staff from other countries to bolster, basically. So I think the average wait time just now for getting through installer on site is between 3 and 4 minutes, which is quite high, and it's because we're in summer holiday season, so some of our service staff will take holidays, for example. We also have a few resources that I just wanted to kind of touch on just before I maybe hand you back to Callum. So a few things I want to discuss. So we have a Solis Europe YouTube page, which is massively important, especially for single-phase hybrid installers. We have a lot of videos in terms of how we'd expect you to fault find. So just looking at examples here, there's no battery alarm on a hybrid inverter. So we've got my colleague Paul going through some of the steps in the lab to show you how you can select, go through the fault finding on that. Meter select fails, so if there's an issue with the meter. And then we have like CT polarity, so that's where we talk about the CT around the wrong way. And then, of course, we have the time of use windows, and then how to set up a Wi-Fi stick. And then there's also this is where you'll find the information for setting up as an organisation for the first time, if you're brand new to Solis, of course. In terms of other forms of troubleshooting, we have what's called the Solis knowledge base. So we have some information here that's going to be continually adding to it. So you can search alarm codes, for example, and it should give you an indication of maybe stuff that you can check on site, or it will advise you to contact our service department. If you are wanting to contact our service department, you can see the top there. It has the submit a ticket tab, which you can do by just submitting information via this. You get a ticket number back to your email, so you can track through that RMA side. And then you can also take that through. What I would say is if it's an urgent thing, then I would maybe give us a call as opposed to submitting a ticket, because it can take, as I say, a day to come through. Whereas if you get somebody on site, you don't want to submit a ticket and then have to send somebody back to site if we've asked a question, for example. So the best thing to do is give us a call. As I said, we'll always get kind of people there waiting to help. Once you select the submit a ticket, you can just go through some basic information. So what country you are, the ticket, and it'll ask you stuff like serial numbers, and then if there's any sort of stuff you want to attach. So if you've taken videos, for example, if we talked about the checking the RS45 on the bottom of the inverter. So there's stuff like that. You can maybe take videos, or you can see if we've measured the battery voltage, for example. Any information like that you can send directly to us. Other ways of contacting us is sending an email. So if you require any further training on any other range, then you can email directly, just requesting. We can also create a ticket. That's just for submitting a ticket. And then we also have the lines. So we have both lines. So we have two. They go to the same pot effectively. So one's the UK line, and then we've also implemented an Irish number so that customers are not getting paid a premium to contact ourselves. So again, make sure it's hugely important. If you're on site, use the priority on site installer side. But thank you very much. I'll wait about once Callum's finished, and we can maybe address some of the questions if there was any.
Perfect. Thank you for that, Matt. I think there is a few questions, so if you could hang on, that'd be ideal. No, but very insightful. Thank you for that, buddy. So I'm hoping everyone can see that there. So I'd just like to touch on a few things quickly before I go into the Installer Excellence Program while we're on the topic of service. Obviously, Dyness being a Chinese company, historically, it's been very difficult for installers in the UK dealing with Chinese companies in terms of service. You know, majority of them have a great product at a very good price, but the downfall is if you were to get a problem with that product, you can't get hold of anyone. So that's where we sort of separate ourselves from the crowd there. You know, we've got a UK presence now, which Matt did sort of touch on earlier. When talking about their partners, a lot of the companies have good products, you know, good price, but the service lacks massively, which is what we're trying to separate ourselves and drive that forward. So you've got myself and Alpa obviously being the sales guys here in the UK. We've recently hired some more engineers based here, got our pre-sales engineers as well, and we will be sort of creating a service team that will be situated in Birmingham and various other places in the UK. So moving forward, you will be dealing with effectively a UK company, which obviously is really good for installers in terms of if they're on site, they've got someone in the same time zone with the same language who they can speak to. Any problems obviously regarding speccing systems or ordering, obviously from the sales side of things, you've got us here already. So I think moving forward, we'll be very well positioned within the market to sort of take that sort of market share. And another thing we're doing as well, which will benefit installers, is the Installer Excellence Program. So what is the Installer Excellence Program? It's something that we are bringing in this year. It's already up and running. We're just obviously trying to get it out there for your guys' sake. It's something where we want to reward our customers for being our customers effectively. So these things can include product discounts, recommendation rewards, marketing tools, customer leads, but overall just make sure you're getting a good service and providing a good service. We want our partners to obviously shed a good light on us, positive light on us, but we also want them to be rewarded for that. So effectively what we're doing is creating Dyness certified installers. So on our website already, you will see it in just a second, you'll see a page or a tab that you can become a certified installer. So you need to submit your registration or your information. And then step 3 is the real-time interaction. So various activities and steps that we'll ask you to do, which I will get into. And then obviously equity realization, which is the reward you get. So here you'll see a installer tab. You just click on installer certification there and you'll see the becoming an installer partner page. Just fill out all your details there and you'll receive an email back, get you all registered. And then from there, obviously we'll send you all the information that you need. So what could these rewards entail? So obviously there's step by step, there's different categories that earns you different points and things like this in order to receive these rewards. But we've got sort of the lower side of things like small electrical appliances. The second one would be larger electrical appliances that we can reward you guys. And then gets better and better to the point where we've actually offered some luxury tours, luxury holidays for installers. But obviously alongside this, on the business side, it's discount from products. So not only are you getting rewarded personally, where you could potentially, if you're a larger installer, reward your team. Let's say we provided iPads because you've hit a certain number, you can hand out these iPads to your team. But obviously alongside that, you have the discount moving forward. So it's sort of a win-win. So you see here how you can obtain some bits. You will receive this in an email anyway, but there's bits like replying to the confirmation email and your point. Case sharing. So if you post our pictures of your installs using our products on LinkedIn, for example, that will earn points. Bits like this, just for us, the benefit is you're pushing Dyness. For you guys, obviously, you're trying to rack up as many points as possible to be rewarded in the long run, both on a personal level and business level. And then obviously we have the points for which products you install. So you've got the DH200F and DH200Y, which are earning the most points, and then the B4850, which are earning the least because it's the smallest. But you've got to think, obviously, if you're an installer that's doing 100 a month, you're earning 1,000 points a month from just B4850s. And you'll see here that 1,000 points a month is the luxury tours side of things. So, if you're a larger installer and pushing Dyness a lot, you're going to be earning quite a lot of rewards, incentives. Ultimately for us, the reason we're doing this is to push as many Dyness as possible, because if you're buying from the wholesaler's going to need to buy from us. So, it's a win-win for both parties. And obviously then we're doing the cashback benefit as well. So we will be doing a rebate based on what level of installer you are. Certified installer, you won't receive anything, but you will qualify for the smaller prizes. And then silver, gold, and platinum is when you'll start to receive that rebate. Another thing that we're doing as well, just to help you guys sell our products, is the Dyness marketing library. So this is where you can register and you'll get access to all of our marketing images and posters and bits like that, just to help you sell our product. If you're using DL5C, for example, you'll want some marketing information on that and be able to provide marketing packs for DL5C to your customers, whether that be data sheet or images or videos even, just so it's easier for them to understand what they're dealing with and what they're buying. So we think that this will really help, obviously alongside the incentive program, to push our products and get our product out there. Ultimately for us, we're trying to take up as much of the market share as possible. And if we've got all you guys on our side pushing us as well, it's going to be a lot easier. And obviously in the long run, you will be rewarded for that as well. So there's some of the things that we're doing on that side. We've also got all the promotional planning. So the social media promotion channels. We've recently set up the Dyness UK account on LinkedIn, which is up and running and posting on there. We're trying to get that to a certain amount of followers by the end of the year. We're well on our way, but obviously with your guys' help and interaction, we will get there. We've got the newsletter as well, which you might received already. That might be why you're on this webinar now, but that we're going to be doing every month as well. The website, we're going to be updating more often, and offline activities as well. Obviously, we work very closely with our wholesalers, whether that be training days at theirs, whether it be sort of the exhibition days where you come and you see a lot of different manufacturers. Will be attending those as well. And then things like this, webinars. So we do a webinar every month. Obviously, this month's with Solis. Thank you to Matt for being here. But we will be doing some with wholesalers as well, and maybe some other partners in the future. And then how you can reach us, obviously, we've got the LinkedIn, we've got TikTok, Facebook, and YouTube for installation videos. That Facebook, there's a forum for Dyness, so you can interact in there. That's the Dyness community, where you've got homeowners and installers where they're talking about maybe any problems they've had or any benefits that they've found that you might not necessarily know about. So definitely suggest jumping in there and just having a read through. But obviously stay up to date on our LinkedIn, because that's where majority of our updates will come, obviously alongside the monthly newsletter as well.